across all the UI stacks. I give you my colleagues, Krammer and Tobias.
Thank you.
Thank you.
Yeah. Good afternoon. This is Krammer. I'm Tobias König. We are both with KDAB, one of the sponsors and hosters of this conference. And today we want to talk about QML across all UI stacks. And normally people associate QML and QtQuick together. It's some new thing. But actually QML and QtQuick are two different things. And today we want to show you how you can use QML together with QtWidgets. So the old stuff that many people that it's outdated, but actually it's used in many areas in the industry today. Yeah, and we want to show you a way how you can migrate from QtWidgets to QtQuick in the future with an intermediate step.
Okay. So what we're going to do is, first we are going to look into the motivation that we had for creating what we call declarative widgets. Then we demo how to do, what we can do with declarative widgets, right? And then we will look at this porting thing, right? We have a widget application, a standard, UI file designer-based widget application, which we will transform into an application using declarative widgets, and I will do that, and Tobias will then show how the same application core can now be used to do an alternative implementation, non-widget based, in this case a BB10 Cascades UI, but with the same application core. That's basically the idea, right? We want to have the same application cores on multiple UIs on top of that, using QML for the as a creation layer for our UIs. And then we have a Q&A session and a list of resources, right, like the URL for the repository.
Yeah, so let's first talk about the motivation. So we know there are QtWidgets for more than 20 years now, and QtWidgets are rock stable, so they are used widely in the industry by thousands of developers. And they are well understood. We know how we can customize them. They are out there, huge applications based on QtWidgets. So this is really a rock-solid technology you can base your application on. The UI is normally created by developing C++ code. So a developer has to create the UI. He has to do it imperatively by writing create new widget, create new button, place the button inside the widget, and so on. So if you have worked with QtWidgets before, you know what I'm talking about. And then it must be compiled, and at runtime you cannot modify the UI anymore. You always have to change the C++ code, recompile, and then re-execute the application. There had been some improvement where the Qt people tried to separate the implementation from the declaration, and this was done by introducing the UI files that you can create inside Qt Designer or Qt Creator with the Designer plugin, where you first declare your UI. This is done in XML, and then you have a tool which takes this description but nevertheless generates C++ code again, and then the C++ code is compiled, linked to your application, and yeah, so it's basically the same again. When the first version of Qt came out, and they also shipped a lot of examples how you can use Qt, normally they suggest that whenever you want to customize a widget or you want to implement your application, you subclass from an existing class like QWidget or QMain window. Inside the constructor, you create your UI. So you put the child widgets, instantiate the child widgets, put it in some layout, and this is all done inside the constructor of the class. And then you have a couple of signals and slots and methods, and inside there you put all the functionality. And maybe as member variables of your custom widget, you put all the data. However, this leads to a tight coupling between business logic and UI presentation, and that's actually something you want to avoid. If you have only a small application, it might not be an issue, but as soon as you develop a non-trivial application, and normally software tends to grow over time, then you will soon run into a maintenance hell. So you should try to keep your UI and your business logic separated. It's always sound easy in theory. In practice, it's a bit difficult. Unfortunately, QtWidgets does not encourage you to do it, to keep it separated. Normally, it's more convenient and easier to write to tie them together. So, the guys at Nokia at this time, so Trolltech when it was took over by Nokia, realized this and they wanted to decouple it again. For this reason, they created this QtQuick stuff. So QtQuick is basically a complete new rendering stack, creating a UI not based on widgets. However, they also needed a way to describe what the UI should look like. And for this, they need a description language. And this description language is QML. However, what's really important, QML is not QtQuick. Yeah, QML is just a language where you can describe a tree structure. But what the nodes of the trees actually are is completely irrelevant for QML. However, QtQuick uses QML to describe the UI tree. And in QtQuick, these elements of this tree are, by coincidence, the QtQuick control, not QtQuick controls, but the QtQuick classes, like a QtQuick rectangle, a QtQuick item, a QtQuick text item, or something like this. Yeah. So these are two separated things. QML just describes the syntax, but the semantic is provided by QtQuick. So, however, QML is not only about the semantic, it only provides some functionality. For example, the property bindings you might have used already when you worked with QtQuick, and also all the framework stuff like loading files over network, and all the runtime environment, the JavaScript environment, and so on. So, when we have QML and we have QtQuick, and they are two separated things, why don't we always use them together? Why not throwing the QtQuick part away, using QML as a description language, and instead of instantiated QtQuick items, why don't we just instantiate QtWidgets? Because we know QtWidgets are stable, and maybe we have a lot of legacy code that is QWidget based. So we can simply use QML to describe the UI, but behind the scenes, we create a QWidget tree, and we can use this created QWidget tree with the rest of our QWidget-based application. So we have an easy migration path.
Right. So the idea is we want to merge the advantages of both QtWidgets and QML. Right. So we want to have still a widget-based UI, which means it will look like as if you had it coded with C++ or with Designer, right? It's the same widgets, the same widget classes are doing all the visualization and the input handling. So there is no difference there, right? Whatever you can do with widgets, you can do. It is widgets, right? So you're just creating the widgets in a different way. We want also to be able to apply existing developer knowledge. So if you know QtWidget classes, right, you know that if you have a QMain window, you have a menu bar in there, then you should be able to transport that into declarative widgets. If you know that there is a property text on a label, then should be a text property on the label class that we are using. Same for layouting and things like that, right? But we still want to have the properties of QML, like the advantages of QML, have a separation or a good suggestion where to have the separation between our UI and the application core. And as a matter of basically advancing our widget application, have a nice way of being able to migrate to other UIs based on QML.
Yeah, so the idea is that maybe in the future, the QtQuick controls that has been talked about in, I think, the two talks before this one by Jens Berre-Weiss. At some point, it's possible to even create huge applications completely in QtQuick controls. But at the moment, they are not, not flexible enough. I think this will take some time until you can really use them in a productive environment. But until then, you can do some cleanup in your code base already. So in the first step, you can use still use QtWidgets to display stuff on the screen. but you can start to separate the actual representation from the business logic. And this can be done completely in C++ code. So you separate the business logic objects, and then you still create your UI imperatively, and you somehow define an abstraction layer in between. But of course, you can also do the separation and then not instantiate your QtWidgets in C++ code, but you can use QML for this purpose. That means you have the description in QML now and the business logic in C++. And for the moment, you use a QML file, and the QML file will then be used by Declarative Widgets library to instantiate QtWidgets. And that's the first step. In the next step, you can modify the QML file to not instantiate QtWidgets anymore, but to use QtQuick controls. As soon as the QtQuick controls are mature enough, it should be just a matter of doing a simply search and replace string operation to convert QML files that describe declarative widgets into QML files that describe QtQuick controls. And when you have taken this step, you can additionally easily port your application to other platforms, for example, mobile platforms that also use QML as a declarative language to describe the user interface. One example for this would be the Cascades UI framework on the BB10 platform. Because you have now a clear separation between the business logic, this is normally implemented in C++ and Qt, so it's by default more or less cross-platform, and you only have to modify the UI layer, or you have to adapt the UI layer for the single platforms. Okay, just to give you an idea how that looks like, I'm going to do a demo. Let's see. Oh, Krammer is still already running. There it is. This one, right? Okay. So every QML document starts with the import clause, right? Import. Our module is called QtWidgets, right? Just instead of QtQuick, I import QtWidgets, right? And let's say I want to make a main window, right? We know in C++ that would be called a Q main window, so we just call the just main window without the Q. So every class here is the same, has the same name, but just without the Q. Okay, let's save that. We have like the QML viewer or the QML scene from Qt. We have like a runner here called Declarative Widgets. Oh, I have to save it. Right, let's save it. Let's call that test.qml. Okay. So Declarative Widgets test QML. Right. Where is it? Oh, here. Right. Oh. Okay. So I just have a window. It doesn't look like a main window yet, right? It has a default window title, so nothing special yet. Okay, let's give it a window title, right? That's a property we know that exists, right? Window title test, right? Maybe we want a menu bar in there, menu bar, right? And inside that menu bar, we want a file menu, okay? So how would we do that in C++? We would get the menu bar from the main window. We would call add menu with a like the file string, and we would get the main window pointer back. We do that here like this, right? We create the menu inside the menu bar, and it's called title, I think. The property, let's see, file. Right, you can use the same syntax that you would be using for the accelerator. Save it again, oops, and run again. There it is. Right, so we see I changed the window title. Right, I have a file menu here. Of course it's still empty. Let's add an action to that. Right, action. Right. Let's say the action text is quit or close. Right. Close.
And in QML, we have, whenever we have a signal, we automatically get, the QML engine creates a signal handler for us that's always on and the name of the signal. We know a Q action has a triggered signal. In C++, we would connect the triggered action to a slot. Here we have on triggered, right? And then we want to close the window. So what in QML, what we do is we just have an ID here, right? We make the window addressable. We call that like root, right? And then here in on triggered, we just call root close, right? Demonstrate again. So again, I have my window here, my main window. I have a file. I have the close action here. If I close it, it closes the window, right? So this is still everything normal QtWidgets, right? This is the same thing. I could have written that in C++. It's just a very fast turnaround, right? I have a central widget, of course, right? I can, let's do it. Text edit, right, as a central widget here. Right. And I have the window with a text edit. Yeah, I can have a toolbar, right? Actually, I can have many toolbars in the main window. Toolbar. Okay. And of course, I want to reference the same action, right? I could create another, let's say, close action. I don't want to do that. What I do is I make that referenceable. I say ID, whoops. Not my keyboard, so my muscles still think that the keys are on other places. So this is the close action, and I just reference the action here using an action item. So this is slightly different to the C++, right? Because we could plug in the action into several places. We can't do that in directly in QML. So we have a proxy here, the action item that we use to reference the close action. Right. So we have a toolbar now, and it also has the close action. We also have support for stuff like dialogues. That's if I add like action. Oh, sorry. More. Okay, let me make the window shorter until it reaches. So, okay. Action. Let's say text. No, it's for action. It's text. Like open, right? And say on triggered, right? Thank you. Right. In Qt, if we want to do a file open, right, we usually use the file dialog, Q file dialog, get open file name. We do the same thing here, right? var equals file dialog, get open file name, right? And then like we could do console log, right? File equals file. Make a semicolon just for keeping it the same way, right? Let's run that. So I have my open action here. If I click the open action, I get the file dialog with the native file dialog integration as we used to have, right? So this one, and we see the log output here in the console is the file that I selected, right? So this is just normal widget stuff. So you just create widgets a different way. The widgets have the same capabilities that they have when you use them from C++. Okay, that was the demo of the capabilities. In our repository, we have a gallery.qml that contains all the things that are supported, including super advanced stuff like tree views, right? Tree views seem to be very difficult to do, so that's why none of the other QML-based UIs do that. But of course, there is QtreeView, right? So we can use a QtreeView, a file system model in that, and show the file tree, just with a couple of lines of QML. Let's go back to the presentation.
Yeah, so this was just a small example how you can use declarative widgets. Now we want to do a bit more extensive example, and within real application, supporting a real application. So the question was, what application could we use? Well, actually, earlier this year, there were serious floodings in the eastern part of Germany, and my house was near a river which was affected by them. And therefore I was a bit afraid how high the water level is. And fortunately, the German administration has a web service where you can request current water levels for every water, so every river and also for the sea here in Germany. So our application, or the application I wrote, just utilized this web service to retrieve all the current water levels that are available in Germany, and you get a list of them, then you can select one and you get more information about where the measurement station is and what the current measurement is. For the backend communication, I used Qt, of course, so a Qt Network Access Manager and QJSON to parse the JSON file that we get from the web service. And then I store it locally to have a local offline cache. And then I have a couple of classes on top of it to retrieve this information. So the entry point to this library, which is called water level, is a water level app class, which does not have any functionality itself. It just acts as an entry point into this functionality. But it has it provides access to a station model. The station model is just a QList model, and actually an adapted or your own QList model. It inherits from QAbstract list model, and it contains a list of station objects. Each station represents one measurement station that is provided by the web service. And it has a couple of roles where you can get information about each station, like the ID, the unique ID, the name of the station, then the water agency, which is responsible to running the station, and also where the station is located with latitude, longitude. And the most important part is, of course, the current measurement. So it has a pointer to a measurement object, and the measurement object contains the timestamp when this measurement was taken, and of course the actual value, so the height of the water level, and also a trend. So it's a value -1, 0, or 1, -1 if the level is going to decrease, 0 when it is to stay for the next days, or +1 if it is to increase. So during the spring I always hoped that it would be a -1, but well, it was not always the case. So,
oh, you wanted to show the application, right?
First I show the application, what it looks like, the C++ version. So we have a class, so the water level stuff is all encapsulated in a library, C++ library. And this library is then linked against the widgets application. If you have a larger software, then I hope that you have put all the code that belongs together in a separated library so that it can be reused. If you haven't, if it's still part of your main application, then the first step for the refactoring for you would be to put it all into a library that can be reused, implement a decent API, and then put it as a separate library and just link against this library. This would be the first refactoring step. I've done this from the beginning because I know this application would be used as a showcase later on. So here we have the class water level instance, which is just a singleton that provides me access to the water level app. So the
maybe just run it. So
sorry?
Maybe just run it.
Yeah, we can run it to show what it looks like. Wait, I have to do it on the console. Keep the micro. So that's what it looked like. You have an action to actually explicitly trigger the update of all the stations. So that's where the web request is going on. I've done it before, so everything's cached locally already. And here you see the station model that provides us with information about the single stations. When I select a station, the information are displayed on this page. and then I can say show current level, and another page is planted in, and depending on whether a current water level is provided or not for the specific station, we see the current level, the trend represented as an error, and the timestamp when this measurement has been taken. So, oops, sorry, wrong window. So this singleton is used as a main entry point. Then, of course, we have a main function in our widget application, which just creates a QApplication object and my custom main window class. That's like it's normally done. And inside the constructor of my main window, I set up the UI. You see the UI has been created with QDesigner, so we have this UI file, which is where we get the generated C++ code from, where we just call setup UI on this. And then I initialize our list view with the stations simply with a model that I get from the library, so water level instant, and there I call the stations method on it. Then, of course, we want to update the station information for the currently selected station, so we have to connect against the selection model to catch this. Whenever the model is reset, we also want to change the selection, and we have to say whenever the updates station information action is clicked, we trigger the refetch of the stations from the web service by calling the slot on our water level app instance. Yeah, and showing the page with the measurement information is done by connecting the toggle signal of our show level button against the visibility property of this third page that contains the current measurement information. Then we do some further initialization on the UI. So you see here we have already some of the business logic and tied together with the UI. Yeah, and then this station selection slot is called whenever the user clicks on one of the stations. In this case, we simply retrieve the information from our model. Our model provides the different roles, so we access the data from the selected index by the various roles and set it as text in our line edits, as you have seen before. And whenever the user selects a station, we do not only fill the page with station information, but we also request the current measurement for the station and fill our measurement page with the information as well. So you see here, we have the water level app as our main instance. Then we retrieve the data from the model, and the model also provides us access to the current station object. This is done by the custom station role. And with this station object, we have access to the current measurement. This is a measurement object we have seen before in the graph. And the measurement object provides us with the timestamp formatted value and the trend information. So this is important to remember this API because we will see it in a second again when we have a look at the other implementations.
Right, so if we quickly look at how this looks in Designer, right? So we have a main window. The main window itself, let's make that a bit smaller here. So the main window contains 3 group boxes. Oh, I should not. Okay, there are 3 group boxes, and they are in a horizontal layout, right? And the middle group box has like a form layout here, right? Always label, line edit, label, line edit. So how do we do that in our Declarative Widgets project? Whoops. Oh, cancel. Right. Okay. Not save. Right. So first, of course, we need a slightly different main function, our main function does not create the main window directly, right? Our main window will be loaded from QML. So what we do, our integration point in our declarative widgets library is a class called Declarative Widgets document, right? Document. We pass in a URL to the QML file, so you could have a HTTP based URL, a local file URL, a QResource URL. In this case, we have QRL from local file, and the name will be main.qml, right? So just tell that's basically internally we have forgot the closing parentheses. So inside this class we have a QtDeclarative engine, which parses the file, and then we create a widget from that. QWidget widget equals document create, and we want it as a QWidget. I could also cast it to QMain window if I wanted to. Right. And this is the QMain window creation, right? Just like in the normal widget application, we still need to show it. Widget show. Right. Okay. So this is the thing we need to do in main CPP. So it's slightly different, but not that different. Well, all the UI now goes into our main QML. Our main QML, we know, okay, it's again a main window, right? I'll leave the toolbar out for the moment. I have a central widget, that's just a widget. I have 3 group boxes, right? Oh yeah, the import, sorry. Good thinking. Import QtWidgets. Right. I obviously did that on purpose, right? Okay, so I have 3 of those, and I want them in a horizontal layout, right? The horizontal layout in QtWidgets is a HBox layout, so I have an HBox layout. Oops. Right around this. Okay, indexing. And indentation, right? So if I build that, right, it builds. Let's run it. Okay. Yeah, I ran it twice. Oops. Right, looks like this. No, that's the wrong one. This one. Okay. So I have 3 group boxes in a horizontal layout. So this is basically how I can recreate the UI. So this is of course very manual, a lot of manual labor. So we are currently working on a tool that you can pass in the UI file, and it will generate a QML file for you. Okay. Just to show you how that looks when it's finished. This is basically the same application using declarative widgets. I use a QML file here as a resource. So inside my resource file, I have the QML file, so that it's not, I don't load. I have it actually built into the application just to be sure that I have it. As I see, I have my main window, right? I have the window title, I have toolbar. This is my toolbar action, and I have this water level app again. In this case, it's an exported context property on the QML engine, and I call the request action slot. In the first group box, right, where I show the list, I have a list view, right, and I set this model as the model. Here I need a connections element to get to work with the onCurrentChanged signal of the selection model, right? I do that by including QtQuick. So in this case, I have to include QtQuick 1.1 in this case because we're in a Qt4 application, and this import is for our application-specific classes. right? So I have in the second group box, right, the one with the line edits, I have a form layout, and the form layout contains a line edit, like a list of line edits, and for each line edit, I set the label of the form layout using what QML calls an attached property, right? So just specified it as like a property that belongs to the parent object inside the. This refers to the parent line form layout. Same for grid layout. So we have like a grid layout attached property where you can specify which cell a widget goes to. So it's slightly different than widgets in this respect, but it's the same thing. As we can see here, we have nested layouts. We have a vertical box layout. Inside that, we have a form layout because we have a button or label at the end that is just in the this below the form layout. Okay. The button Tobias showed the toggle signal of the button was used to show or hide the additional section. Here we do that with a property binding, right? We set the visibility property of the group box to the checked property of this button, right? So this is something that we don't need as write to code for, not a signal slot connection or a slot or something like that. Okay, so this is basically how that would be ported, right? All the functionality is inside this water level app object that Tobias also showed, and it exports everything already in a way that we would need for QML. Naturally, in a real porting situation, you would first have to, or you would, while creating the UI, you would see which properties or which things you have to export to QML to do that, right? You would probably, in a C++ application, you could have a manually create instance of the model. In this case, you would also either export as a context property or in the like we do it here as a property of a main object. Right. Okay. Oops. Yep, that was it. Yeah. So step 2.
Yeah. So step 2 would be that we now try to port the application, which is now based on QML as description language, but QtWidgets as rendering stack, to another platform, BB10. And there we use also QML to describe the UI, but it uses a different rendering stack. So there we don't use QtWidgets, but we use the native Cascades rendering, which is basically an OpenGL scene graph. So similar to QtQuick 2, but different. Yeah. Okay, before I show you the code for the application after it's ported, I want to point out another thing about the declarative widget file that we here have. So you see we have this water level app object here, but we have never explicitly set it as a context property inside our C++ code, so inside our main function. So where is this water level app object exported? Well, basically it's exported inside this plugin that we load here. So this is a QML plugin. QML plugins are a way to extend the functionality of your QML runtime. And it's basically a couple of C++ classes together with an initialization function. And this initialization function is called whenever you import your plugin inside a QML file. And exactly inside this QML file, exactly inside this plugin here, we export the water level app object as a context property into our QML context. So why do I want to point it out? Because here we see that all the functionality is really encapsulated inside the plugin. We do not have any other app-specific initialization code inside this application. So here inside the main CPP, we see nothing about water level, right? All the water level stuff is pulled inside only in the QML file. That makes it now easy for us to port it to another platform. Because in Cascades, when we have a look at what our project will look like in Cascades, oh, sorry, wrong window. Because in Cascades, the startup code looks a bit different when you want to set up your declarative environment. so here you also have an application object, which is basically a Q application under the hood. And then you have a custom class that is shipped with Cascades, which is QML document, where you also pass the QML file. And then you get the top level object that is declared inside this QML file, which is a custom class that is shipped with Cascades, which is an abstract pane that is basically a container, a pageable container. And you set it as a main window of your application, and then you start the application. So the code looks the same. And we want to achieve that when we port our water level application from QtWidgets to Cascades, that we do not have any application-specific code inside the main function, because that would mean we would have to maintain whenever we change water level, then we also would have to modify the main functions or the startup functions, the initialization code of all the platforms where we want to run our water level application on. So this is purely Cascades code, nothing involved with water level. So let's have a look at the main QML file.
We also make sure by that we don't fall into the trap of trying to access the UI from the C++ code, right? So the C++ code that knows nothing about any of the UI implementation. So the UI is the one that calls into the C++ code. The C++ code does things for the UI, but the UI can be changed, and due to the separation, we can't even access the UI, right? Because the C++ code doesn't know, or the water level code doesn't know about any pointers, right? It doesn't know about the widget pointer, and it doesn't know about the abstract pane pointer. So we are protecting ourselves from accidentally accessing stuff in the UI.
Yeah, correctly. Yeah, and this is a main QML file for a Cascades project. They also use QML, so you see they have these element tree. However, they use completely different elements. Yeah, they use a navigation pane, which is imported by their own plugin. A navigation pane is just a stacked widget where you can put pages on top of each other and then go back. So it's something like a tree navigation. And in our case, we simply push our station page on it, which is just a separated file that we have in our project. And inside the station page, we see some familiar code. The first thing is we import our plugin. That's the very same plugin that we used in the QtWidgets application, in our Declarative Widgets application. That's the very same file that we import here. Well, I have to cross-compile it for BB10, of course, but the source code is exactly the same. Yeah, and then we have our page. We have an action again where we can refresh the stations from the web service, and you see they also used a similar syntax like we did in Declarative Widgets. And whenever you trigger the action, we just call the request station method on the water level app. So exactly the same as you have seen in the C++ code when you just use plain QtWidgets, or in our declarative version. With Declarative Widgets. Yeah, we also, whenever we triggered the action, we just called water level app request station. Yeah, then we have a list view. The list view requires a model to work. Unfortunately, the Cascades guys did not use QAbstractItem model as a model interface to interact with their list view. They use their own model types. Therefore, you need an adapter that adapts the QAbstractItem model to the Cascades model interface. We have implemented one, which is also accessible under BSD license, so you can take it if you need it. It's a class which just takes the QAbstractItem model. In this case, our stations model, which we can again receive from the water level app by accessing the station objects, and there we get the QAbstractItem model. And the adapter is then plugged into the list view. Then we define the delegate, so what the single items inside our list view should look like. And here we access the role names of the model. So we want to show the station name and the water name inside the items. And whenever somebody or whenever the user clicks on one of these items, we access the station object. So here we access a real QObject pointer, and we store this pointer in the station property of our page that we have newly created, and then we push this page on the navigation pane. And when we look at this, what the station page look like, the property where we assign our QObject pointer to is just a custom property of type variant. So in QML, properties of type QVariant can store QObject pointers, which is quite convenient. Yeah, and then we have again another action which triggers the update of the current measurements data, and below we simply show the data of the station. So again, the station name, agency, water name, and the distance from the source of the river to where the station is. And below we have another label where we show the current measurement of the station, and from there we access the formatted value. So if you have the graph from the beginning of the talk in mind, it's exactly the structure that I showed you that we can here access just by concatenating the single elements with points. So it's quite straightforward to use. So this is an API that we actually use from QML to access our business logic objects by just accessing the properties and reacting to signals that these C++ objects emit. Yeah, and I can show you what this looks like when we run it. So here we have the list view with all the stations. We have the action to refresh the stations, and then we can select the station, and here we see the data that we have requested from the web service presented.
Yep. Okay, so that's how we basically can move a widget-based or standard widget-based application to an application that we can, where we have like almost all code shared between a desktop application and a mobile application by using Declarative widget as an intermediate step or as actually the final version of the widget of the desktop-based application. So we could even have different desktop-based application depending on user profiles or whatever, right? So you could have like an advanced user interface or a basic user interface, things like that, right? Because you always have all the functionality in your plugin, and the UI file just uses, or the QML file just uses whatever it wants to use from that. So a couple of resources. So we're working on that. That's free software. It can be found in our GitHub repository. Yeah, it works with Qt4 currently, so we wanted to show that it's not depending on Qt5 or QtQuick 2, right? So it's normal widgets. It's currently building with Qt4. It's just a normal Qt project, so you can run it with QMake. We're still working on that. As I said earlier, I'm currently working on a tool to automate the porting from the UI file to the QML file. Okay, thanks.
Questions? Oh. When my widget have some self-defined widgets, for example, I add in the QLine edit a clicked signal. Can I also add it there?
Sure. If you have your own widget class, you just need to export it. So what you do is basically you need to register your type with the QML object system. So there is you just call QML register type your class and the name you want to export it to. So you could call it my line edit, whatever. So you can use, if you have custom widgets, you can just export them to the QML type system and just use them the same way. So maybe you can open the Declarative widgets document CPP just to show how we do that, but you can do that as well. Yep.
Okay. How do you port animations like moving widgets or changing transparency?
Moving widgets or changing transparency.
Yep.
How do you do that with widgets?
Or I move the widget from the top of the screen to the middle, and
Okay.
or from left to right.
Oh yeah, okay. So you want to do, you have a widget that is not in the layout and you want to move that.
Yep.
Okay, yeah, that's not a problem. All the geometry properties of widget are exported as QML properties. So you have an X property, Y property, width property, and so on. And if you import the QtQuick module, it has all the property animation, so you can move, you can just animate the X or Y property. There is no transparency property for QtWidget, so you can't change the transparency, but you can change the visibility. Right, but you can modify all the properties that QtWidget has with property animation. So you can do a color. Okay, right. So we have an animation QML file that shows stuff like that, right? So just using QML property, QtQuick property animations. Right, so I have a sequential animation, right, that loops infinitely. Yeah, it modifies a delta property that's a local property, and just creates the new geometry of the widget. That's why I can do like a pulsing button or a bouncing button. So this is just what you can do with QML. So.
Any more questions?
Yes.
Is there a way to transform automatically user interface in QML file, or the transformation is manual, is only manual?
Now that's what I'm currently working on. So I started with that the week ago. I can already create most of the structure. I still have to do all the advanced layouts, but the idea is I have like a UI compiler, right, like the UIC. So you call that, you pass in the UI file, and it generates a QML file for you that has like as close as I can get to what the UI file can offer.
Okay, thank you.
So if there's not any more questions, I will just ask for another question.
Sure.
Last one.
Is there a tool like Qt Designer to generate
right, to visually edit the scene? Not yet, no.
But
we could probably do that, yes. I don't think we have currently time for that, but that would be something that could be done, right? So it's just widgets, so it should, basically we would need to have the designer not generate the UI file, but generate QML,
yes,
right?
Yes, thank you.
So now for real, last round of applause for our...
Thank you.